Hoo-hoo-hoo. Welcome to the next section, going modular with PyTorch. Now this is a very exciting section, but before we get started, let's start how we always start. Where can you get help? Number one rule, follow along with the code. If in doubt, run the code. All of the code resources you need will be on the GitHub, so if you get stuck, you can reference them. Then of course, try it for yourself. Write the code, try it out, see what comes out. Press Shift, Command, and Space if you'd like to read the doc string. If you're still stuck, I'd recommend searching for it. You'll come across resources such as Stack Overflow or the very helpful PyTorch documentation, which we've had plenty of practice with so far. Then of course, try again, refer back to the motto, if in doubt, run the code. Finally, if you're still stuck, you can always ask a question on the PyTorch Deep Learning discussions page. So the discussions page for this course. You can go new discussion. You can select a category, Q&A, or anything else here that you like, such as maybe section 05, and then what is going modular. And then if we come down in here, and then video number, doing this will really help us out, help you. So video number might be 171 or something like that. I'm not sure exactly what video number this is. This is just an example. And I'm not sure what going modular is. And then you could click start discussion, and then someone will help you out answering that question. But speaking of what is going modular, how about we answer that question? So this is the whole goal of this entire section, is to go modular. And what do I mean by that? Well, you might have written some nice code in a notebook. You might be wondering, can I reuse it elsewhere? And in fact, we have. We have written lots of nice code in plenty of notebooks so far. And a lot of that code, we've had a bit of practice now writing it a few times, and I've done that on purpose because one of the best ways to practice code is to write more code. But now that we've had some practice writing training loops and data loading and whatnot, we might want to reuse it. So the whole premise of going modular is that yes, you can reuse your helpful code, and that's what we want to cover in this section. Reuse the most useful code from our previous notebook in Python scripts. Let's get a little bit more specific here. Food Vision Mini is what we built in the last section. We loaded in some data, or we wrote some PyTorch code to load in some data of steak, sushi, and pizza images. We built and trained a model to identify different foods. Then we made some predictions with the model, albeit they weren't as good as what this graphic is showing. It did get a fair few wrong, but that's okay. What we want to focus on in this section is turning all of the code here that we use to load our data, to build a model, to train a model, into a series of Python scripts. We're going to finish up with a directory structure like this. So we'll have a top-level directory called Going Modular after this section. Then we'll have a subdirectory also called Going Modular. And then within that Going Modular subdirectory, we'll have a series of Python scripts. So one to prepare the data, one to train and test the model in the engine.py, one to build our PyTorch model. We've built a PyTorch model a fair few times now, so rather than rewrite the code every time, we can put that into a Python script. Then we'll have train.py, and then we'll have utils.py, and finally we'll also end up with a models directory that's going to contain our different trained PyTorch models. And our data is going to be in the same format that we've used over the past couple of sections, and that is standard image classification format, our images of pizza, steak, and sushi. But this is another thing to note. You could customize this in almost any way, shape, or form you like. And the same with your data. It really depends on the problem you're working on. But this kind of structure here is often how you'll find PyTorch code in the wild. But we'll get to that in a second. Here's what we really want to do. We want to be able to train a PyTorch model with a single line of code. And with that single line of code, it would be great if we could pass in different hyperparameters, such as which model to train. How big should our batch size be? What learning rate should we use? How long should we train for? Now, this is a command on the command line. We could run Python, train.py, that's our target script. We want to train some model. We want to use a batch size of batch size. We want to use a learning rate of learning rate. We want to train for num epochs. Now, these flags here are called argument flags. We'll have a look at that later on. But here's an example. if we wanted to train our tiny VGG model from the last section, we could write Python, train.py, model tiny VGG, batch size 32, learning rate 0.001, number of epochs 10. And of course, you might be guessing, could we add more hyperparameters here, such as number of hidden units or number of layers or something like that? And the answer is yes. This could really extend out to 20 different hyperparameters, to 30, to 10. Doesn't really matter. It's infinitely customizable. And so what this line is essentially saying is train the tiny VGG model with a batch size of 32 and a learning rate of 0.01 for 10 epochs. Now, as I mentioned before, this is often how you'll find PyTorch code in the wild. Yes, of course, you'll find them in different notebooks, but this is the Detectron 2 documentation. Now, Detectron 2 is a computer vision library from Meta or Facebook that uses PyTorch. And so if we see here, we've got trainnet.py. That's going to train your neural network on 8 GPUs, it looks like, with a certain configuration file. And then if you wanted to train with 1 GPU, you notice how there's another argument flag here. You just change that to 1 GPU. And you can change a few hyperparameters here. But that's trainnet.py. That's a Python script. The same thing goes for this Torch Vision. So we've been using Torch Vision. So that's from the actual PyTorch library itself. This is how they do object detection. So if you go to pytorch/vision/references/detection, object detection, you'll see there's a bunch of Python scripts here. There's train.py, utils.py, engine.py. The same thing here on the PyTorch blog post where they train state-of-the-art computer vision models with Torch Vision. They use Torch Run, which is a way of running your PyTorch scripts or your Python scripts. I'll leave that as extra curriculum if you want to look into it. But here's train.py. There's the model. They're using ResNet 50 with a batch size of 128, a learning rate of 0.5, a learning rate scheduler of cosine annealing LR, a learning rate warm-up epochs of 5, learning rate warm-up method linear. There's a lot of different hyperparameters here, a fair few, a bit more that are outside the scope of this course, but the principles we're going to cover are much the same. We want to write a train.py script by the end of this section that's able to train our model. And then same thing here. This is a brand new paper at the time of recording called conv-MAE paper on GitHub. Now, they run Python, submit it, fine-tune.py, a Python script. So I just want to share with you my workflow. It's not necessarily the be-all and end-all of workflows. It is just one example. So this is one of many options to turn your useful notebook code into Python scripts. So I start with Jupyter/Google Colab notebooks because they are great at experimenting and visualizing different things. And then, if I've written some useful notebook code in some code cells, I move the most useful code to Python scripts. So it's still PyTorch code here, import OS, from Torch Vision, import datasets, transforms, from Torch utils.data, import data loader, and this might be called datasetup.py. And this is what's going to set up my data. And here we return a train data loader, a test data loader, and class names. We're going to have a look at how to create one of these files, or many of these files actually, in the upcoming coding sections. Now, there's two parts of this section, or two notebooks of this section that you need to be aware of. One is cell mode, and one is script mode. What we're going to be doing is we're going to start with a cell mode notebook. So this is Notebook 05 Part 1, cell mode. This is nothing different from a normal Jupyter notebook, a normal Google Colab notebook. We're going to run it from top to bottom. It just executes Python code in cells just as we've been doing throughout the rest of the course. Now, this is part 1. We're going to use that as the basis to move to part 2. Now, the script mode notebook is going to turn our useful code into Python scripts using a Jupyter magic command. Now, this is something to be aware of, or something you can look up as well. A magic command is something that starts with double percentage sign. Now, there's other magics that start with a single percentage sign, but ours specifically starts with a double percentage sign. Then we're going to write file, that's the command, and then going modular/modelbuilder.py will write whatever is in this code cell to a script of the name modelbuilder.py in the going modular directory. Now, we're going to see this in action later on, but this is just something to be aware of. This section comes in two parts. Part 1 is a notebook that is cell mode. Part 2 is script mode, which is going to turn the code from cell mode into Python scripts. We're going to adhere to our workflow, of course. We've seen this a few times now, so we can jump through it a bit. But what I want you to be aware of is that each of these little sections here, because they kind of function within themselves, they do interact with each other, but they can all be individualized into different Python scripts. And that's what we're going to see throughout this section. So each of these could be turned into a Python script. So one to get your data ready, one to build a model, one to train the model, one to, well, fitting is part of training the model, one to evaluate, one to save, etc., etc. And finally, what we're going to cover broadly, well, we've already gone through a fair bit of this, but we'll see how we can transform data for use with the model. We've already done a bit of that. We're loading custom data with pre-built functions. We're going to build Field Vision Mini to classify pizza, steak, and sushi images. This is the main one we're focused on, turning useful notebook code, all of the above, into Python scripts. And finally, we're going to see how we can train a PyTorch model from the command line. And how, well, this is a machine learning cooking show, so we're going to be cooking up lots of code. With that being said, let's code. I'll see you in Google Colab.